All right, we are trying to invert linear functions. We're trying to find the inverse of it. So it's kind of that balance over that y equals x line. But we want to do it algebraically this time. So in this, there's a process that we usually go through here. So our first step is, let's go ahead and make it y equals, change it from function notation to the y equals style, 5x minus 15. All right. The first step is we switch the x and the y. So it now becomes x equals 5y minus 15. So notice everything is the same, but the x and y switched. Now we solve for y. So we try to get y by itself. So I'll go ahead and add 15, and I get x plus 15 equals 5y. So last step to solve for y, divide all terms by 5, or both sides by 5. I like doing it all terms. That just simplifies the process a lot more. So every term gets divided by 5. That now gives us y equals the x over 5. It's just like a 1/5 is in front of it. So let's go ahead and put it in that y equals mxb notation that they want here. X, 5 goes into 15 3 times. All right. And then the last step is we use the notation of the inverse, which would be f inverse of x equals 1 over 5x plus 3. Now let me just kind of go, it says find the inverse function in slope-intercept form, mx plus b. So here's our m, here's our x, here's our b. And the process is, it's a little bit tricky to kind of get used to, but basically this is always that kind of same step of finding the inverse, is you switch the letters, solve for your new y, and then you replace it with the f inverse notation. 1 divided by 5, x plus 3. Got it. So let's see, they changed it to y. Yep. Then they switched the letters. Yep. Solve for y. Yes. And that's it. Okay. Let's see if the next one's any different. And done exactly in the same way.